Welcome back to Discovering Geometry with Mrs. Berry. This is lesson 22. We're starting chapter 4, which is all about triangles. In this lesson, we'll have an investigation about the sum of the angles of the triangle, and then we'll look at the third angle conjecture that will help us relate it all together. Triangles have certain properties that make them useful in all kinds of structures, from bridges to high-rise buildings. They are very rigid. And if you can see in these pictures of bridges, they also, when put together, create parallel lines. Because of these things, they are very strong. Our first investigation is about the triangle sum. I want you to draw some different shaped and sized triangles on regular paper. Make sure at least one is acute and one is obtuse. And if you cut off the edge of a piece of paper, you could have a right triangle as well. Measure the three angles of each triangle as accurately as possible with your protractor. You could even write on the paper what those measures are. Now find the sum of the measures of the three angles in each triangle. Is the sum of every triangle the same? We can check the sum another way. If we label the interiors of the three angles and then carefully cut out the triangle. After you do that, you tear off the three angles. That is, you tear the triangle into three pieces with the angles intact. So if you tear from side to side, you'll keep the angles intact. Arrange the three angles so that their vertices meet at a point. How does this arrangement show the sum of the angle measures? Try it with another triangle. Then we'll complete our conjecture about the triangle sum. So here are my triangles, and you can see that when I measured them, they all totaled 180 degrees. I'm tearing them apart from side to side so that my angles stay intact, and then I'm lining them up, and they're all forming this straight line. And we know that straight lines add up to 180 degrees. So our triangle sum conjecture is that the sum of the measures of the angles in every triangle is 180 degrees. So we can prove it as kind of a paragraph proof. Let's talk through that. To prove the triangle sum conjecture, we need to show that the angle measures in the triangle add up to 180 degrees. We want to start by drawing any triangle. We'll label it ABC. And then we're going to add a new line segment to it. It's called, that we might label EC. So it's going to go across the top of the triangle, and we want it parallel to the base, the AB line. When we draw this extra line in, we call it an auxiliary line. It's an extra line that we drew. We didn't need it in our triangle, but it's going to help us with our proof. So in this figure, we could say that the measures of angle 1 and the measure of angle 2 and the measure of angle 3 add up to 180 degrees. And we can do that because we're considering the measures of angle 1 and 2 as one together, because they are adjacent angles and we can add them up. So the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 are a linear pair. And we know that linear pairs add up to 180 degrees. When we also see that EC is parallel to AB, we can look as AC as a transversal, and then angles 1 and 4 are alternate interior angles. And if we look at CB as another transversal, then we see angles 3 and 5 also as alternate interior angles. So their measures must be equal because alternate interior angles are congruent. So by substituting the measure of angle 1 and the measure of angle 3 in this first equation, we can change it into something else. So instead of 1, I'm going to put in 4. And instead of 3, I'm going to substitute 5. So now my equation up here reads the measure of angle 4 plus the measure of angle 2 plus the measure of angle 5 equals 180 degrees. So we see 4, 2, and 5 add up to 180 degrees. Therefore, the measures of the angles in a triangle add up to 180 degrees. So what about our third angle conjecture? If 2 of the angles of one triangle have the same measures as 2 of the angles of another triangle, what could we conclude about the third pair of angles? So I have a triangle over here. We'll maybe call it ABC. And then I have a triangle over here. Maybe it's DEF. If A is congruent to E and B is congruent to F, what do I know about C and D? We can use patty paper to convince ourselves of this. If you draw a triangle on your paper and then create a second triangle on patty paper with 2 of the same angles, but draw a longer side in between. Finish the triangle and compare the third angle of the original triangle to the third angle of the one that you drew. Do that on your own now. So hopefully you've seen this third angle conjecture. If 2 angles of one triangle are equal in measure to 2 angles of another triangle, then the third angles in each triangle are equal in measure as well. So let's see that in action. Here we have 2 triangles, ABC and DEF. Is C congruent to angle E? So we see that A is 60 degrees and D is 60 degrees, B is 70 and F is 70. And we want to know if those last angles in the triangle are congruent. By the third angle conjecture, because angle A and angle B are congruent to D and F, then we just said that C, the third angles, the last ones, C must be congruent to angle E. We could also use the triangle sum conjecture on this, and we could find that angles C and E both measure 50 degrees. And how would we know what C measures? Well, the total triangle should be 180 degrees, and if we subtract A, which is 60, and we subtract B, which is 70, we're going to get 50 degrees, and that's what C is. We can do the same thing over here for E, 180, minus F, which is 70, minus D, which is 60, will give us 50 degrees as well. And we could find that because C and E both measure 50 degrees, they are congruent.